So thanks for having me here. I've been told I shouldn't walk too much, which is kind of challenging for an Italian. So I'll try to stick to my position and say something without moving too much. So if you see me moving, just raise your hand or say something. Um, I work at MongoDB. I actually joined MongoDB from Oracle. At Oracle, I was responsible for the MySQL pre-sales unit in EMEA, and at MongoDB, I'm responsible for business development and strategy in EMEA. So I'm going to guide you through what I think it's one of the overlooked facts around big data. So big data is not always about something that is big. And I'll try to convince you that the most challenging part of managing big data solutions is not the big part, but is to handle the variety of data and the velocity of ingestion of that data. So why do I say that? We've run a survey, not we, but Gartner, and asked the CIOs what is the top challenge around big data. And the answers that you can see are not really comforting. So most of the CIOs don't know what big data is. They struggle to manage big data, and they struggle to find who should do what regarding their data. And another interesting research shows that actually 64% of respondents think that the most important challenge when managing big data is not, again, the big factor. Only 15% of them have databases with a data set that is more than 100 terabytes, and 20% of them less than 100 terabytes. So probably, let's say on average, we can say less than 20 terabytes. The most difficult part is analyze data from different sources, analyze streaming data, and analyze new data types. So ingest diverse and new data sources in real time. That's the real challenge around big data. And we think with MongoDB we can solve pretty well these challenges. And the funny thing is, unfortunately, I landed a bit late, so I didn't see all the presentations. But going through the speakers, I recognize Hadoop and some companies that are sponsoring Hadoop. I attended the Microsoft speech, and we're partnering with all of these companies because you can't really solve big data issues with just one single technology. You need to put an architecture in place to solve different type of problems. So given that most of the CIOs don't know what big data is, we should think a bit more like Thomas Edison. So he said, this quote is pretty famous: "I've not failed, I've just found 10,000 ways that won't work." It's pretty smart. It's another way of portraying failure. But in reality, that's pretty interesting for big data because, as we said in the beginning, we don't know what big data is. We don't know how to manage it. We don't know who should manage it. So we should plan for failure. We should make sure that the tools we use are built to be iterative, to have short development cycle, to use agile methodologies, to try and fail, and then reach the success afterwards. So I'm going to ask you to raise your hand. Who is using the audio tape anymore? Nobody? The black landline phone? Well, at the previous conference, there was a girl. She said, no, I have it at home. And she was using it again. So this is just to show you how many things changed since the 70s. You recognize probably most of them, but if we talk to someone who is less than 20 years old or maybe less than 16, probably they don't even recognize some of these things because they are not used anymore. So let me ask you to raise your hands again. Who is using a relational database? I think that most of you didn't raise your hand, but you're using it anyway. And if you see, this is the paper that gave birth to the relational database. I'm not sure if you can see the date, but it's November 6th, number 6 of June 1970. So the technologies that we've shown before are all died. Relational databases are still present, and most of us are using relational databases. So the question is, are we using old tools to solve new problems? Is a relational database the right choice to handle big data, and to handle in particular the operational big data, so the data that is not just big, but that should scale horizontally, handle huge amount of transactions in real time? Is this the right tool to use? Well, I don't think so. And again, I joined from Oracle, so I needed to be converted from relational databases to NoSQL solutions. And I can say that I'm now convinced that in the past we were using relational databases because they were the only tool available. And now we have choice. We have Hadoop, we have NoSQL technologies like MongoDB, so we can be more flexible, more agile when handling and managing big data projects. Because a database makes development hard. So who is a developer here in the room? Raise your hands again. Let's say probably 20% of the audience. I think someone has never raised any hand, so probably they are either sleeping or I'm not saying interesting things. But the interesting part here is when you build an application with a relational database, you have your database schema. That is how you interact with your database. Right in the middle, usually you put something like Hibernate, or what we call ORM, the Object Relational Mapping. And the reasons why we use these technologies is because the way in which we build an application doesn't fit well with the relational database. You don't normalize your application in Java. You don't have tables in your application. When you use object programming, the only thing you have are objects. So we put something in the middle to hide the complexity of the database and to build efficiently applications on top of the database. And even worse, when you have to change something, if you want to add a new attribute to your object, you probably have to add a column or a new table. Or if you want to add a column in your table, you need to move all the other columns and fit in the table. And this is not really efficient. We have customers who are saying in the web that for them, in order to add a new column to a production database, in that case it was with MySQL, it took them 3 months because of the huge data set. And 3 months on the master, and then additional 3 months per each and every slave that had to propagate the change from the master. Is this efficient? Well, probably not. Probably you are losing a lot of time in building your data model, in mapping your application to the relational database, and the result is not efficient at all. So imagine you are going to a car parking lot. You hand over the key of your car, and what the guy does is basically take your car and disassemble it and put it in many different places. Put the wheel in the place where they store all the wheels, put the gear stick in the place where they store all the gear sticks, and so on and so forth. Is it efficient? Yeah, probably it is. It's efficient in terms of space. And relational databases have been so successful because they solved one problem, which was the cost of storage. The initial issue with computers wasn't really the performance of the CPU, it was more the cost of storage. And storing data was a pretty expensive exercise. So relational databases were very successful because you take your object, you map different tables, and you make sure that your data is not replicated. You make sure you're not saving your name in one table and then again your name in another table, and so on and so forth. It's like what we are doing here with the car exercise. We keep a car, decompose it, and then put every piece in the right place. But again, That's a problem. And databases are very expensive to scale. So you can't really scale horizontally with a database. There are some tools that may help you, but if you want to scale to very, very high workloads, you probably need to buy pretty expensive hardware. And you're lucky because now they can also run without a raised data center floor, which is pretty interesting. But again, what we think is that big data shouldn't be a big upfront payment. It shouldn't be related to big upfront investment. You should use open source solution. You should use tools that, as I said before, allows you to try and fail. And the beauty of open source is I can download MongoDB, for example. I can start to build my big data applications and projects on MongoDB. And I usually pay something to the commercial vendor behind the company when there is value, when the project is important, when I need support, when I need additional tools. So I can try, fail, and then at the end reach success with my big data projects. So what we propose is a dramatic change from complexity to simplicity. What you see on the left-hand side is a traditional ER diagram. Everyone probably in the room knows it. So you have your tables, your relationships. It's not really easy to understand. It's probably easy here, given that I have 15 tables. But imagine the data model that we've shown before with hundreds or thousands of tables. It's pretty challenging to understand it. What we propose is a document approach, and MongoDB is a document database. And a document is not really a PDF or a Word document or an Excel spreadsheet. It's more of a JSON document where everything is represented as a JSON object. And on these documents, you can do pretty much everything you do with the relational database. You can do queries, you can have primary and secondary indexes, you can do projections, group bys, whatever you want. It's just, we say that it's a NoSQL solution because you don't use the SQL dialect. You use our JavaScript interface to do that. And MongoDB is not the only NoSQL technology in town. But in the top 10, I'm not sure if you're familiar with the site dbengines.com, but in the top 10, you have 9 databases, 9 relational databases, and probably one single challenger, a document database called MongoDB. And if you go on dbengines.com, you'll see there are 200 databases as part of that ranking. 200 databases. Isn't it too much? What should I do? If I'm a customer, what should I do? Well, the experts in innovation, they claim this is the classic concept of the long tail. So in the beginning, you have a lot of interesting ideas, a lot of hype, a lot of interest in new technologies. And then after a while, in the long tail, you start to see products. So inflected expectations in the beginning, a lot of different technologies, and then as they mature, they move from being just projects to being products. Well, it didn't work out so well. In the beginning, you have all the interesting ideas, and then it's not a long tail anymore. It's usually a short tail, because what happens is that most of these ideas are designed to fail, maybe because they don't have a company behind, they don't have the financial resources, maybe they don't have a big enough market. So most of these technologies, of the 200 solutions that we've spoken before, are probably designed to fail. Maybe not in the short term, but we'll see a lot of consolidation in the NoSQL market. So what should I use if I need to start a big data project? Well, again, we use a survey from SiliconANGLE, and the 2 most popular technologies when talking about big data are Hadoop and MongoDB. So if you need to choose 2 technologies, one for operational big data, the other one for batch processing or crunching huge amount of data, well, probably you need to choose Hadoop for the backend, and MongoDB for the operational part. And we hear a lot about this new role, the data scientist. So someone that joins your company after studying mathematics for 45 years. He works for 5 years and then he retires. And then magically, he understands all of your data. He applies some algorithms trying to extract the intelligence from your data. Well, it's probably easier to start the other way around. If you talk to your people, if you talk to your DBAs, to your developers, you probably have people that already have the knowledge of what your company does. They know the data already, so they can quickly apply some simple rules trying to extract information from the raw data. So again, you need to leverage the existing skills. This is from the 451 group. It's a research showing the number of LinkedIn skills with different NoSQL technologies. And again, in the top spot, there is MongoDB. And then you have others. You have Cassandra, Redis, HBase, CouchDB, Neo4j, and so on and so forth. This is just the top 10. If you go down all of the 200 different technologies, well, there is probably someone who knows one specific NoSQL solution. And again, maybe that specific product is absolutely great for a single use case. So should I adopt 200 different products within my company, or should I leverage some technologies that can be used extensively? And we think also that the search can be used as a sign, the number of searches can be used as a sign of where the market is headed. On the top, you see the number of searches. You can try it yourself using Google Insight for search. Searches for Oracle, MySQL, SQL Server, and it kind of breaks my heart because I joined from MySQL and Oracle, but in reality, the interest in relational databases is going down. The interest in technologies like MongoDB and Hadoop is growing exponentially, and the reasons are what I said before. We were trying in the past to solve new problems with old technologies. Now we have new technologies to solve and address additional problems. So, when to use Hadoop and when to use NoSQL technologies. As I said, we partner with the commercial sponsors of Hadoop. We partner with a lot of companies that are providing services around Hadoop. And we see a lot of complementarity between MongoDB and Hadoop, and even between, in a sense, MongoDB and relational databases. Why? Well, the enterprise big data stack has changed. In the past, when you had to manage your data, you probably had relational databases and enterprise data warehousing technologies. So relational databases being Oracle or SQL Server or I don't know, or MySQL. Enterprise data warehousing technologies like Teradata or Netezza. And that's it. Now we see two new opportunities. On the operational big data side, for online data, you can use relational databases for something and MongoDB. On the backend side, for offline data, you probably want to store as much data as possible on your Hadoop cluster, and maybe you need some of the specific features of enterprise data warehousing databases, and then you choose to keep your Teradata or Netezza or Vertica or whatever. So we have new options. We have new architectures available. So the database market in the past, I would say, the data management market, to be clear, it was pretty boring. So in the last 25 years or 30 years, we didn't see too much innovation. Then we started to see vertical databases, columnar databases, and then we started to see Hadoop and NoSQL. So there are a lot of new technologies that you can leverage within your company. And our approach is, regarding MongoDB, don't use it for everything. You don't just throw away your investment in Oracle, in SQL Server, or in other technologies, and then you move to to MongoDB. Start with some projects, identify some projects where MongoDB gives its best, and then expand from that. And I don't have it as part of my slides, but if you want to learn MongoDB, you can go to education.mongodb.com. There is a free online training course. It's 7 weeks, and the effort is 10 hours a week, more or less. And at the end, you can even get a certification. It's using one of the tools built by Stanford and MIT to deliver online university courses. So it's not just watching a webinar, is watching a teacher, getting some exercises, having them corrected, and then at the end you can learn how to build on MongoDB, how to administer MongoDB, and you can learn where MongoDB gives its best and where it doesn't make where it does make sense to start projects on Mongo or where it doesn't. And then you have obviously the infrastructure side. It's pretty challenging to scale relational databases in the cloud. It's not so easy. If you think about Oracle, you have Oracle RAC, but you need to have a storage area network, and you need to connect all your servers to the storage area network. And between the nodes, you have what is called the global cache. So it can scale up to a certain number of servers, but it doesn't scale well in the cloud, and it doesn't scale linearly. That's true. And it's not Oracle as technology, it's the fact that with relational databases, with all these tables and all these relationships, you can't work in the cloud with many different nodes, with hundreds or thousands of nodes that are not connected one to the other. So we need new technologies that can be leveraged in the cloud, that can be used to build new mobile applications. So the world is changed even in the sense of how we build applications today. We use agile methodologies. We interact pretty quickly with the applications. We don't spend weeks or months gathering the requirements, because the requirements are probably changing every day. So we start to build things, and we use agile methodologies to change our applications pretty quickly. So when should I use MongoDB, or when should I use Hadoop? This is how we see the world. Online, capturing data from sensors, tracking whatever you do on your mobile, connecting to a website, whatever that requires a real-time response. Low latency and high availability is pretty important in the online world. Let's say I did the math for a previous conference. I don't remember exactly the numbers, and I forgot to check this. But imagine Amazon. So if Amazon goes down for an hour, how many transactions are they losing? How many millions are they losing? Probably a lot. That's true almost in all the online use cases. The high availability is pretty important. Your servers, your services should be up and running 24/7, 365 days a year. And then there is the offline world, where you have long-running queries, long-running MapReduce jobs. You have usually high latency, because if it's long-running, if it's offline, you don't really care if your result is coming back within 1 millisecond or 10 or 2 seconds. You don't care. And the availability part, I'm not saying that's not important, because some of the use cases that we'll see require high availability on the Hadoop side as well. So they need high availability, but it's lower priority. Said in other words, you can't have everything in a single product. So we see MongoDB used for the online world and Hadoop used for the offline data. And I'll give you some examples. Hadoop is good for risk modeling, churn analysis, to build a recommendation engine. It's good to do advertising, targeting. It's good to do trade surveillance. and so on and so forth, and network failure prediction or search quality is good for the data lake cases in general, where you have a huge amount of data. You need to crunch that data and provide some recommendation based on that. And I show you some cases where our customers, so these are in production customers, are using Hadoop for exactly these type of cases, and MongoDB for example, 360-degree view of customer. What is that? Let's say in the insurance business or in the telco business, you probably have one customer, let's say me, Luca, that is using the landline service. They may use your mobile services. They may have bought some solutions or tools or services from some of your partners, and throughout the years you may have acquired some new companies. So you end up with one customer that is not perceived as one in your systems. You have disparate and different systems that are treating Luca as a single entity. So how can I solve that problem? Well, usually, to give you a concrete example, we'll go to that later in details, but you put MongoDB between your applications and your backend systems. And you store everything in a document named Luca, in my case, and you connect all the data from the different systems to that document, and you enrich everything you have around Luca by connecting every time to a new system. And when I buy a new service, I don't need to change anything. I just connect, because MongoDB, one of the things I didn't say, has a flexible data model, so I don't have to spend time in building the ER diagram or the JSON or UML diagram. The data model is flexible. So if I connect a new data source that gives me more information around Luca, maybe what I do on social networks. I liked what the Microsoft guys said. Maybe I'm opening a claim to an insurance company, and is not for an accident between me and my wife, but is for an accident between me and someone who is connected to me in social networks. Well, you can use MongoDB in the middle and enrich the data related to Luca by connecting to his social network profiles. And that's just one case, mobile and social, which is again pretty similar. You need to interact very quickly. You need to connect to different sources in real time, or fraud detection. Can I wait for hours before detecting a fraud? Probably not. Can I wait for minutes? Well, probably not. The best way to handle fraud detection is in real time. Or user data management. Again, I want to collect all the data around a single user or multiple users, but make sure that I know everything about him or her. It could be a CRM, it could be an ERP, but I want to have a complete picture of what my users are doing. Or content management and delivery, again, or reference data or product catalogs. We'll see much more in the following slides. An interesting one that I like a lot is M2M, machine-to-machine apps, or the Internet of Things. Why is it so good for a document database? Well, because if you think about it, every sensor is a document. So you can map a sensor to a document and store all the data related to the sensor. And the beauty of MongoDB is you can analyze all your documents and gather more intelligence around what your sensors are doing, what your machines are doing, trying to find the, the needle in the haystack. And Data Hub is another use case which is pretty similar. Again, I connect to different sources, I enrich the data coming from different sources, and then I build applications on top of that. Imagine what some large companies are trying to do. So they have a lot of legacy systems in the background. They probably use IBM technologies or Oracle technologies, but they want to reduce the costs of these technologies. So is it really easy to say to the IT department, you have Oracle, you have IBM, you have whatever you have, and throw everything away and move to a new technology like MongoDB? Probably not. The easiest thing to do is to put a kind of caching layer in the middle and try to build new applications on top of this caching layer. And the caching layer can be MongoDB, connected in real time to the databases that you have in the backend. But again, the beauty of MongoDB is it's not just a caching layer. So it can actually store your data, save your data, and a piece at a time, you build the new application on MongoDB and you disconnect the initial data source. And you build another new application and you disconnect the data source, and so on and so forth. We have customers in production with clusters of 1,400 nodes, and they have this concept of a huge data cluster. So all their data is stored in a single cluster with different systems in the back, where the MongoDB cluster is retrieving data from. And in the long term, then the old applications are becoming old, and they phase them out and reduce the costs of the infrastructure. So how to use MongoDB and Hadoop together? I'm not sure if you are familiar with this website. Is whereiswaldo.com. You should try it. It's pretty funny. As you can see, the overall picture is important. It's really important to have an holistic view of what's happening. But the way in which we do marketing has changed. In the past, we tried to segment customers by age, by location, but by some fixed attributes. Well, that's changing. The new trend is segment a customer by behavior. So I never played Angry Birds, but I've heard this example. If you think who is using Angry Birds, who is playing with that game on the iPhone, or Cut the Rope, or some of the other viral games that are available on the mobiles, you can find kids, 5 years old, 4 years old, and you can find even people who are 40 years old or even 60 who have family. So you have a family where the father, the mother, and the kids are all playing Angry Birds or Cut the Rope. How can you segment them? How can you find some categories for them? You need to find their behavior, and the behavior is individual, and then you have to roll up to the big picture, try to categorize different individuals who don't have anything in common, but a single behavior. And that can be done only leveraging offline technologies and online technologies together. I'll give you an example, not really specific to the marketing side. I have 5 minutes, so I need to run. Online travel. If you book your trips using, I don't know, I use Kayak. I like it. And I need to search in real time the flights. I need to book them in real time. I want to get meaningful offers in real time, something that is interesting for me. And the system in the backend is using my profile, is using the reviews done by other travelers, and is using metadata to give me a very, very good service. But in the back, I usually connect to Hadoop. I need to do user segmentation to offer some recommendation engines that are available. They crunch the data, they try to identify the behavior, and then they move the meaningful part of data on MongoDB to process it in real time using the MongoDB connector for Hadoop. Or, for example, I've been interviewed before this call. They asked me if I think that big data can change lives. And I said, well, it's really a bold question. Well, in some cases it can. The city of Chicago is using MongoDB together with Hadoop to do predictive analysis for crime or to try to predict health issues. And the challenge they have on MongoDB is to analyze a diverse, unstructured set of data, including 30 data from 30 agencies. And what they do, and they need to correlate the data in real time, because if I spot a crime 2 hours after the crime was committed, well, probably it's too late. And they use Hadoop to try to identify long-term trends. And they connect MongoDB to Hadoop in real time. So the data in MongoDB is stored in Hadoop, and the data in Hadoop is put back to MongoDB to be analyzed in real data. And the case I said before, the insurance company who needs to connect to different systems to have a 360-degree view of customers is actually one of our customers, is MetLife. They've built a product called the Wall, and they make it available to the call center guys. And when I call MetLife, they know everything I have already. They can recommend a new insurance policy based maybe on the analysis that I've done in the back with Hadoop, but based also on the real-time data that I'm connecting from 70 different systems. So the case study is available online. And machine learning is another nice case. Criteo is one of our best customers. I would say we work very well with them. It's an advertising company. They are based out of France. They went public recently. So with Hadoop, they store catalogs, products, they store user profiles, click, views, and transactions. So everything that is online. And then they move data to Hadoop to do segmentation, to use algorithms to build a recommendation engine, or to try to predict what happens when someone is clicking on an advertisement. Is he going to buy if I show to him this type of of picture or not? Is it better to use something different? And so on and so forth. So again, technologies used together. And it makes sense to, in your big data architecture, that's the bottom line of what I wanted to tell you. It makes sense to check the technology landscape, to try to identify a few good technologies that can solve a broad set of use cases, and then go and adopt them together. So go at home, use MongoDB, use it together with Hadoop, try to leverage MongoDB where it gives its best, and try to leverage Hadoop where it gives its best. And that's it. Questions? There is one over there. Are there mics? There. Sorry, you are exactly on the other side. I hope it's not too difficult.
No. Thank you. First an observation and then the question. You should talk to the MapR guy because he said that Hadoop is not only for batch processing now. And the question is, what in your opinion would be the main strength of MongoDB against its competitors like CouchDB or others like that?
Sure. First, a comment on your observation, which is I've been with the MapR guys at the Pentao Partner Conference as well, and we really position the technologies together. While it's true that Hadoop is not exclusively for offline, it's also true that MongoDB is not exclusively for online. So you can use MapReduce within MongoDB. I'm just saying that these two technologies have been built with a goal. Hadoop was built to handle offline data and to crunch the main value of Hadoop in the last, when it was built, was MapReduce and the distributed file system. Now it's changing, but it's built from an architectural perspective to handle offline data. MongoDB is the other way around. It was built by the founders of DoubleClick, and they sold the company to Google to handle real-time operational big data. So it's a matter of the architecture, but you are right. You can store online data on Hadoop. And I forgot the question.
What's the strength of MongoDB against the main competitors like CouchDB?
I would say a lot of things. So without going too deeply into the technology, I don't think technology is the only thing that matters. I think What we have in common with technologies like Couchbase is the document model. Where we excel at is in the broad adoption. So we have way more users, we have way more people who knows the technology, and it is pretty important when you need to adopt the technology, because otherwise, if you need to hire someone who knows COBOL, for example, today, it's pretty challenging. If you want to hire someone who knows MongoDB, there are a lot of people out there. The ecosystem is another important thing. We have around 300 partners, and a database is not a solution on its own. So you usually need to connect to a database and do business intelligence. You need to connect to a database with an ERP or with an ETL tool. And the broad set of partners available, also implementation partners as well, is pretty important. I don't think I'm qualified in comparing the two technologies, but that's why I slightly changed your questions. If you want to go down into the differences from a technology perspective, I can put you in touch with some of the essays. I don't want to say things that are not correct. Any other question? One. Over there. Easier than the previous one, please.
Hello. I would like, maybe this is like a technical question, but as a developer, how do we cope with eventual consistency problems with NoSQL databases?
That's actually a good point, and that was probably the second question after the salary when I decided to join MongoDB. There are a lot of misperceptions around eventual consistency. So MongoDB is an ACID database. So you can commit, and when you commit, you are sure that your data is there. What you don't have is multi-statement transactions. So you can't work on two different documents, and if you have a failure on one, you roll back the other as well. So you have the ACID characteristics at the document level. So it's not an eventually consistent database. You have strong consistency. The challenge is you can't really do multi-document transactions. You can't do what you do with the database, begin transactions, insert, and then roll back, and you roll back the 3 inserts before. You can't do that, but given the document model, probably everything you need is stored in the same document. You don't need to go back and connect to 20 different tables. Does that answer your question?
Yes, so if I understand it, the place where you write is the place where you read, which is, I think, important for consistency.
Correct, and you can even say, I will write, you can even write to multiple nodes together. So you can write to, I don't know, 10 nodes in parallel, and then you can read the data wherever you want. So the consistency level, so to speak, can be defined with Mongo. Yeah, and you can even just write fire and forget. So write and don't even care if you've reached your disks. So it's configurable, but it's strongly consistent in the strict sense of the term at the document level.
Thank you very much.
You're welcome. There was probably another. I seen.
Yeah. It will be the last question because we are running out of time.
Okay.
Luca?
Thank you.
There's no more
questions?
We can take one more question, a last question.
One more.
And then I'm sure Luca will be available to take questions one-to-one if you want to.
One more.
Is there somebody else who wants to?
Question.
Okay, one over here.
1 year.
Hello.
Hi.
How big is the data that we can put into MongoDB? How big, really?
In terms of size?
Yeah. Petabytes?
I don't know exactly the size of the biggest cluster. I know we have 1,400 nodes, so you can go up to petabytes. The beauty of MongoDB, I didn't show the architecture, is you can have your node and scale horizontally. So you can keep your, let's say you're handling millions of users. Every user is associated to a document. You can put 100,000 users on one node, the remaining part on the other nodes, and scale horizontally. So it scales pretty linearly. I have some numbers in another presentation, but you can really scale.
Hundreds of nodes, then you can put hundreds of the nodes. With
Sure, yeah, the biggest, the one that I know for sure, because I remember the number, is 1,400 nodes in production.
Impressive.
I don't know how big the database is, but I can look.
Thank you.
You're welcome.